Good morning. My name is Michael Charmella, and I'm the VP and General Manager for Highcon in the Americas. On behalf of our entire Highcon team, I want to thank you for sharing your time with us today. We're excited today to share with you our vision for digital manufacturing for both corrugated and folding carton applications. Over the years, Highcon has provided innovative solutions to help with old world production challenges. Since our start in 2009, we have helped companies all around the world bring the flexibility and speed of digital finishing to their companies. We've grown substantially since our start and now have about 80 systems in production all around the world. With the growth in demand for e-commerce and short-run, quick turnaround work, companies are looking differently at their production processes. The tried and true manufacturing methods that work well for long run work may not fit the needs and the time to market requirements when it comes to short run to mid run volume applications. Our digital finishing solutions are a catalyst that allow companies to take an entirely new approach to on-demand and short run manufacturing. Today, you will see in a live demonstration how we bring the power and the flexibility of digital to eliminate the costly tooling and the longer finishing times generally associated with packaging and display manufacturing. But before we start, just a few logistics. We'll be recording today's session, so it's available for later use and for anyone who missed the live session. The recording will be sent out tomorrow in an email. Since we have a large audience, and welcome everyone, we'll have all of attendees will be on mute, but you're encouraged to ask questions by using your chat box at the bottom of the screen. At the end of the session, we'll have time devoted to answer all of your questions. I hope you enjoy your next hour with us. Thank you all again.
My name is Simon. I'm the VP of Marketing here at Highcon. Remarkably, I've been involved in analog to digital for almost 30 years. When I started, that meant replacing an analog step with an equivalent digital step. Just that. Today, when we talk analog to digital, it's more than just changing a step or two. It's all about adopting a digital mindset. Highcon makes equipment that does digital finishing, or more specifically, digital die cutting, which includes cutting and creasing. We achieve the same results as an analog die cutter in many cases, but we do it in a totally different way. We'll be talking about that in the broader context of digital manufacturing in this session, in this webinar. And I guess that raises the question, what do we mean by digital manufacturing? Let's start by saying I'm a converter and I've just received an order. This box is the representative of an order I've never received before. If I follow the conventional workflow, what do? I take this box, I lay it out as many times as I can on a sheet. When I'm satisfied with the layout, I'll order a die, I'll make a set of plates, I'll put it into production, and then when I'm finished, I'll deliver the job, I'll put that die into storage and I'll wait. It might be reordered again next week, next month, next year, or not at all, right? I don't know, but every job that comes in is a new job, a new layout, a new sheet, a new setup, a new die tool, and so on. Okay, that's all well and good, but not all jobs are going to be wanted in large quantities. Not all jobs are going to be reordered over and over again. Not all jobs, not all customers are willing to pay for tooling. And not all jobs can wait a few days to be fulfilled. That's where digital manufacturing comes in. When that order comes in, I start by asking myself some questions. I stop and I ask, 1, what is the volume the customer wants? 2, what's the probability of repeat orders? 3, what about tooling? Is the customer going to be willing to cover that cost? And then if the answers to those questions mean that actually it's not such a great idea to use a conventional workflow, I have 2 choices. I can go and do it digitally in the same way that I've done it conventionally, put as many times as I can that box on the sheet, print it digitally, finish it on the Highcon without a die, without tooling, and I've achieved the same result without tooling. Or I can stop and say, hang on, do I have any other jobs in my queue that are running on the same substrate? Can I bring 2 or more jobs together, gang them on the sheet, perhaps get a layout that is more efficient with less waste? By having more jobs on the sheet, I have fewer setups, fewer make readies, I gain something. And if I can, then that is a huge opportunity. You sit there, you're nodding your head and you're saying, okay, I get it, but how am I going to do all those gangs? And my answer is that you are not going to do them. You're going to turn to artificial intelligence, and more specifically to Phoenix AI, the remarkable software that comes from our partners at Tilia Labs, now ESCO. Phoenix AI will take all the jobs in your queue. It'll look at the data related to those jobs, the quantities, the substrate, the delivery dates. It'll look at your production assets. It'll take everything into account, and it'll generate a set of productive, profitable, and timely production plans. By doing that, what you achieve is, excuse me, you can eliminate tooling, you can eliminate lead times, you can eliminate minimum order quantities, you can eliminate costs, you can reduce the number of make readies, you can increase your throughput, you can increase your flexibility, you can reduce the delivery time for jobs, and you can be more sustainable because you're not making all those dies with all the sustainability impact that's involved in a die. Let's see how Phoenix AI does this magic. Over to you, Eddie, and thank you all very much.
Thank you, Simon. Hello, everyone. My name is Eddie Perez, and I'm the Solutions Consultant and Customer Success Manager for the Americas in Highcon. Today, I'm going to show you imposition AI using Tilia Labs Phoenix. For that, I've predefined a Lambda S10, a Highcon Beam 2, and a Highcon Dart, which is the die making tool for the Highcon. You can see them all right here, down on the left side. Up here, I've also loaded 5 different SKUs. For each different individual product, I've defined or predefined its quantity, its stock type, grain direction, and bleed options. You can also define many more, right? Now, Phoenix also allows you to choose different stock types and predefine those. For today's session, I've defined an E-flute that you'll be seeing running. Now, I'll open imposition AI engine and I'll run it. You can see that actually in seconds, right? The count is still going. You can see that in seconds, I get a lot of results, dozens actually. Those results can be sorted by cost, by time, waste, and many other filters. Once you're happy with your selection, and here I'm gonna take the most cost-effective way, I'll just double click it and I can see the suggested way to produce, or the most cost-effective way to produce these layouts. All you have to do now is actually to export this for printing and for cutting. These can be on a normal format, files. So what has just happened right now? I've loaded 5 different products, and yet I'm going to produce only one layout, one press make ready, one die, a digital one. Now let's move on to the production floor in Israel and watch Lambda printed sheets being digitally finished on a Highcon Beam 2. Over to you, guys.
Thank you, Eddie. Hi, everyone, and thank you for joining us. I'm Arnon Grach, Product Marketing at Highcon, and with me is Morris. He'll be helping us running the system for this demonstration. We're at Highcon headquarters, standing right next to the Highcon Beam 2. This system runs up to 5,000 sheets per hour, depending on the layout and the material. In today's demonstration, we'll start with running a production job. It's a folding carton, ganged layout with 5 products. It's the same layout that you just saw Eddie create on the Phoenix. During this production, I will give you an overview of the key components and technology of our system. And afterwards, we'll see the results, and we'll run a new job, a new setup from scratch, and we'll see the results for that job as well. Both of these jobs were printed by Landa Digital Printing. Basically, Highcon systems are print agnostic, so it doesn't really matter the type of prints or inks. So this first job, the setup is already done. Morris, let's kick off by running the production. Okay, we're standing next to the feeder. This is a standard pallet-based feeder. Quick and easy to set up. And is running for substrates ranging, any stock ranging from 8 to 36 points. That's 200 to 900 microns, and for microflutes. The sheets then move on to an initial mechanical alignment and then pass through optical sensors detecting the leading edge and print marks. For folding carton applications, which typically run print side up, we have a top camera detecting the print mark. And for corrugated applications, typically running with the print side down, we have a bottom camera for detecting the print mark in order to achieve an accurate registration, even if there is a print-to-print variation. The sheets then move on to the Highcon Dart creasing station, where physical creases are applied to the sheet. You can see the upper drum is holding the creasing rules, and there is a lower drum holding a special blanket that applies pressure on the sheets, counter pressure, while the sheets are running through the drums. The creasing rules material is a high-tech material, giving the strength and durability needed in order to run in high speeds with consistent performance. Let's move on. We'll take a brief look at the touchscreen user interface. This is where everything is controlled, the job setup, operating the tool. You can see the speed of this job is 1,000, a little bit more than 1,700 sheets per hour. And we'll take a look as the sheets move on into the laser cutting station, where 3 lasers, powerful lasers, are simultaneously cutting the sheet, each laser with the 1 kilowatt of power. Highcon is committed to environmental responsibility, and if you can see the smoke that's emitting from the cutting process, this smoke is filtered and vented out. And we use accredited lab to measure and validate that our systems comply to regulation and standards and are safe to the environment, including what is extracted from the chimney. Sheets then move on to the integrated inline stripping station, where all the internal parts and waste are brushed off the sheet and collected into waste bins situated under the sheet. After this station, the sheets are safely stacked in the stacker. Okay, we did an overview of the system. I think, Morris, we can stop this job and take a look at what we just produced. This job, as I mentioned before, this is printed by Landa Digital Printing. It's a 14-point or 350 GSM SBS substrate. Let's take a closer look and zoom in, have a good shot where we can see the laser quality. Okay, let's take a look at the creasing lines, the uniformity. You can see the crease lines against the print. You can see a good registration in this area. See if you can zoom in onto the junctions of the creases. Let's find a good spot here. Try to look at this area and see very clear crease ending rules, no bulging, no deformation or cracking of the print. Okay, let's take a look at the we also have, of course, we're supporting these products with nicks, which basically are applied during the pre-press. But we have a great option for something like a last-minute editing, where on the touchscreen user interface, we can edit the nicks. We can delete nicks, add nicks, even change their sizes according to whatever stock we get in a matter of seconds. Now let's take a look at the quality of these packages here. I try to zoom in so we can really check out the quality of the registration, which is really crucial, especially for folding carton applications. Okay, if we take this and fold this, look at that. Beautiful. Five different products on this layout. Okay, try to see if you can check the registration here, the crease lines exactly on the edge of the print. Very nice. Okay. So I think we've completed this job. We saw the quality. And let's start with the setup of the next job. It's a laminated E-flute. We're starting the job from scratch. I'll look at the time. It's 22 minutes past the hour.
And while Morris starts the setup, Arnon, we're going to have a little conversation about this, right?
Sure.
This was the press sheet that we were running. It doesn't look like the kind of press sheet we normally see when we visit converters, does it?
No, because normally we'll see one job per sheet. Sometimes we might see more than one SKU if the die lines are the same, but that's rarely the case.
And why is that?
Pretty simple. The rule of thumb is one job per sheet. That way you can reuse the tool based on the assumption that almost all jobs are reordered.
But of course, that assumption is becoming less and less true today, right? Trends like web to pack, shorter product life, changes that happen all the time mean that packages are still, many of them are reordered, but an increasing number are not reordered, right?
Exactly. And if you look at this sheet, we have 5 SKUs, 4 different structural designs. All of these were produced on a single sheet with a single setup. If you create a job like this, it's a single job. The layout is unique. The creasing scheme can be a consumable, and that can be amazingly effective.
Okay, I'd actually like to make a point. Somebody observed in the chat box during my opening speech that it only works if you need the same number of each job on the sheet. To which my answer would be, you can always choose. If one job you need twice the quantity, you can put it 2 up. You can put it twice on the sheet in order to balance the quantity. If I'd been a converter, I would have had these jobs in. I'd have used my Phoenix this morning. I would have created this layout on my digital press over there, the lander that I don't have that was used to produce this job. I would have produced it and have brought it to the Highcon, to the beam. We could have cut it almost immediately and we'd be ready for folding gluing. And the truth is, by the evening or tomorrow, we could be shipping it. And that is the implication of digital manufacturing. That is the revolution.
Exactly.
Of an entire digital mindset.
So
Okay.
let's take a look and see how Morris is progressing with the job setup. Okay, so what we are seeing right now is the writing of the creasing rules. So this is Highcon proprietary technology at its 5th generation. Once we load the file to the system reads the file, reads the creasing information, and then extrudes this photopolymer material. This is designed and manufactured by Highcon. We specially design and optimize the viscosity of this material while it's being extruded so we can control the exact height and shape of the creasing rules. We can even control and have a different height for a cross grain direction and a different rule height for a grain direction. It all depends on the application and stock in hand. We can also control the pressure that we apply between the drums, the pressure of the crease rules on the sheet. So we have a lot of variables, and let's call it a lot of degrees of freedom that we optimize during the job setup. And all of this in order to achieve the best quality, the optimal folding force that we need for our products to go through folding and gluing and further on to erecting and filling. After the rules are written, they are then cured by a UV lamp, making them hard, strong, and durable to run up to 50,000 impressions. And this dart foil can also be reused up to 5 times for repeat jobs. Okay, so this process, the curing, the writing was about 5 to 6 minutes. The curing will take another minute. We can take this, I'd like to show you some real jobs that our customers are producing on their Highcon systems. Our solutions range from folding carton packaging, corrugated packaging, and corrugated displays and components. I think there are some nice examples. We can see big brands using packages that were produced on the Highcon. Folding carton package. Let's take some example of, yeah, these are pretty regular packages. Okay, we also have corrugated packaging for this mailer, this shipper. We have this products for placing on the shelf. And I'd also like to show you some examples where our customers can really get good benefits by producing on our system. And I'll start with added value by laser cutting. So there's a nice example of a print-free corrugated package, okay, for spirits. These are 3 bottles of rum inside. And you can see this is a unique box. There's no print. There's no print embellishment, saving costs on print. It's just a brown corrugated box with added value by the Highcon laser cutting, something that probably a conventional die cutter could not do, for premium packaging. Another example we picked up in an airport somewhere in Europe. You cannot say that this does not stand out on the shelf. Print-free, corrugated, added value by laser cutting. If we take a folding carton example, there's a nice chocolate box done by one of our customers in Sweden, adding value with the laser cut, giving it the premium look and feel. And now let's talk about sustainable packaging. This is an important point. Same customer, this same box also replaced the plastic upon his own client's request, replacing the plastic trays with paper cut and creased on the Highcon for sustainable packaging, mono-material packaging. We have customers going into this. You can see another example, mono-material packaging, replacing the plastic trays with paper, making the whole cycle much simple and environmentally friendly. Highcon technology uses a non-crush process. And this is especially important for corrugated packages. We recently had a peer review publication by a leading European university. What, the job is running. Wow, that was fast. So let's take a look at the time. This is 30 minutes past the hour. So how long was that? 8 minutes. Okay, so Morris will still be checking out the quality of the setup that he's done, and we'll soon see what he's doing. So I was saying the analysis that was done was testing the box strength of packages produced on the Highcon system compared to boxes produced conventionally. The conclusion was that boxes produced on Highcon are stronger than boxes produced conventionally. And this means that you can produce the same box on the Highcon using a lesser grade of material. That means you can save costs, and you can also help on lightweighting of shipping packages. Another major benefit I like to talk about is laser perforations, opening mechanisms, the unboxing experience. We can also use the lasers for locking and tamperware. Let's look at a nice example. This is something one of our customers, one of my favorite, using the laser perforation, very creative design. And once opening, you can see the laser is working in line with the design. This is a real special box. You can basically do anything with laser cutting. And you don't need to plan ahead. You don't need to iterate with knives as in a conventional tool. We fine tune the laser no matter what the stock in a matter of seconds. I'd like to show you something else. Some say seeing is believing. In this case, hearing is believing. Okay, hope you were able to hear that crisp sound. It's a lovely box. It's all about the unboxing experience when we use the laser for these types of laser perforations. Now I'd like to show some examples. Okay, we're done with the production. Okay, I still want to say one last thing about these examples. And some of these products are produced, how our customers produce these products in order to replace very expensive tooling costs. So one example is a shelf. This is a part of a large display. It's a shelf. It's a corrugated E-flute. And when there are many types of holes, you can imagine the cost of the die tools, the stripping tools, and the amount of time it would set up a conventional tool. So this is really replacing, okay, let's put this on here so you can see, exceptionally expensive tooling. I talked about the non-crush process. If you can see, the corrugated board here is cut crisp and clear. There's no deformation, no crushing as you would typically see in a conventional die cutting. Now let's take a very simple example, a small folding carton box, vitamins. Creating a die for this, these are very expensive dies. The setting up the tools for this is long. The stripping tools are also expensive, and the whole setup. We have customers producing these simple small boxes because they can still remain competitive in their pricing Even if they're not doing the short runs, they can run up to 10,000 or 15,000 sheets and still remain competitive because they're reducing all of these exceptionally expensive costs. Last sample, I have to go through this also. Luxury rigid boxes. Okay, we have customers producing these. Basically, what we do, we are cutting the solid board inside, and later on, it's wrapped with a thin wrapping paper. So I'll just show you one of the things that we do. This is, we cut the solid boards. And for these kind of boxes, you really need the premium look. It cannot be crooked. And the precision of the half cut is very important. Setting up conventional dies, conventional tools to have the exact precision leveled for the half cut is also something that takes a long time. This type of application comes out very easily on the Highcon, very accurate, okay, laser precision. And for this specific example, we can also see that the trays inside are also cut and creased on the Highcon. Okay, these are complex trays. It's a two-story tray, and everything is set in one box. Okay, let's go see what's up with the production of the second job. So this is running. We finished the job at about 8 to 10 minutes. This is during the time I was talking. This is the stacking of the sheets. As I mentioned, this is a laminated E-flute. Okay, and let's take a look at the product. We can stop the system. And let's see what we have here. Okay, again, these are shelf-ready packages. You can see the intricate cutting, the design for the laser cut. Okay. So I have a request after we've seen these. I've got a request in the stack. If we can see the stripping lines. Okay, do we have stripping lines in this area? Okay, and what we've been asked is to see the stripping lines and see how we are blanking this sheet. As you can see, we're blanking the outer part, and the inner parts, the particles inside, have been stripped out in our inline stripping station. Okay. So I think we've completed what we've planned for today. And I'd like to summarize what we've seen, what we talked about. We talked about digital manufacturing and the concept of turning around jobs as a gang, in opposed to one by one, increasing the entire shift throughput. Also, maintaining the efficiency of the conventional die cutters by keeping them running on the long runs. We then showed how we do this digital manufacturing with a Highcon solution. We started with Eddie, who created the layout, the gang layout, using the Phoenix software. It was then printed on the digital, on the Landa digital printing. Thanks again, Landa, for providing us these impressive sheets. We then produced the jobs on the Highcon beam system. We showed the production and the quality. We talked about the technology and the components of the system. And we did a setup from scratch for a new job, demonstrating a fast and agile setup with no waiting for lead times. And last, we talked about customer jobs. I showed you some real jobs that our customers are doing. And I focused a bit on added value with laser cutting, sustainable packaging. We talked about What else was there? Opening mechanisms, laser perforations for opening mechanisms. And we talked about how our customers use the Highcon systems for replacing exceptionally expensive tooling costs, die cutting and stripping tooling costs. In our next webinar, we'll be showing our solution for nonstop corrugated production with our nonstop Beam 2C. So I think we're open now for any questions.
Thank you, Arnon. And we've had a bunch of questions. The question one was one we referenced before, but we had some sound problems apparently. The question was, can the ganging also manage different quantities? Arnon, please repeat what you said before.
So, of course, you can do the calculation and try to understand what is the most effective, but that's where the Phoenix AI-based software, okay, Tilia, where he knows the software, understands and knows to do the calculation for what is the exact number and how to place the apps to get the most profitable run.
So for example, it'll put 2 up of the same job if it needs twice the quantity. It understands that and it takes it into account in the way it creates layouts.
Yeah, exactly.
Okay, question 2. How many impressions for the creasing blanket?
Up to 250,000 impressions.
So that's an awful lot. Question 3, are different creasing heights possible?
Yes, as I explained, this is due to our technology, which we design and manufacture in-house. We control the viscosity of the photopolymer when it's being extruded. And by doing this, we control the height and the shape. And we can create a different height, for example, for cross-grain direction, and a different height for grain direction. So we can achieve the optimal creasing pressure and folding force that we need.
Thank you. The next question, which I think you can also handle, Arnon. What's the maximum thickness the machine can handle or cut? Can it handle double wall material?
So this Beam 2, it's for folding carton substrates from 200 to 900 microns. That's 8 to 36 points, and micro flutes. The Beam 2C for
micro flutes up to
2 millimeters.
Up to 2 millimeters.
This is up to E flute, and we have our Beam 2C product, which can run corrugated boards up to 4 millimeters, currently without double wall, or double E.
I have to be honest, I'm not sure I understand the next question. It says the stripping station can remove waste from each kind of box.
I don't understand, but I can explain what the stripping station does. We talked about the stripping of all the internal parts. So when we design the layout, there are pieces of waste, okay, in the layout. And what the stripping area does is basically brush off these waste particles and debris, and they basically fall down into collection bins, which are situated under the sheet.
I believe that's all the questions that I've been sent. I'm just going to ask the back office team, do we have any more questions to answer, please? And Chaim, maybe you send me a no just to be certain that there's no broken down communication here. Just a moment, please, ladies and gentlemen. Okay, no, that's it. So at this point, we would like to, on behalf of the entire team, those in North America who were speaking, Michael and Eddie, and on myself, Morris, who operated the machine, and the back office team, Tal, the cameraman, and so on. There are lots of people involved in making this happen. We hope it's been informative. The entire Highcon team is available to follow up with you, to answer your questions and to move to the next step. We will be sharing an email with a link to the recording tomorrow, and we look forward perhaps to welcoming you on a future webinar, or indeed to engage with you in all kinds of other ways. Thanks for taking the time, and enjoy the rest of your day. Thank you very much. Bye-bye.